There are billions of galaxies in our observable universe, and each one contains billions of stars. Our Milky Way galaxy is one of those galaxies with a diameter of 100,000 light years. The Milky Way galaxy has about 250 billion stars. Our Sun is just one of them. There could be at least one planet in orbit around each star. The closest star to our Sun is Proxima Centauri. That is 4.24 light years from us, which equals 40 trillion kilometers. A light year is the distance light travels in 1 year. That means it will take more than 4 years to reach the star, even if we travel at the speed of light. For this, we can understand the enormity of our Milky Way galaxy. Our solar system is located about 27,000 light years away from the center of the Milky Way and orbits its center at a speed of 828,000 kilometers per hour. It takes about 230 million years to complete one orbit around the galactic center. Neptune, believed to be the last planet in our solar system, orbits the Sun at a distance of 30 astronomical units from the Sun. 1 astronomical unit is the distance between the Sun and the Earth, 150 million kilometers. So 30 astronomical units is 4.5 billion kilometers. But if you ask if that is the limit of our solar system, it's certainly not. Our solar system is spread farther than that. Astronomers believe our solar system formed about 4.5 billion years ago when massive interstellar clouds of gas and dust collapsed on themselves, giving rise to our Sun, which anchors our solar system. After the formation of the Sun, other planets formed and began to revolve around the Sun. Planets, dwarf planets, moons, asteroids, comets, and meteoroids revolve around it. What are the peculiarities of those planets? And what is the exact boundary of the solar system? Let's see. The Sun. The Sun is the largest object in our solar system. It has more than 99% of the solar system's total mass. Our Sun is a medium-sized star belonging to the yellow dwarf-type star, with a diameter of approximately 1.4 million kilometers. Its gravity holds the solar system together, keeping everything from the most significant planets to the smallest debris in orbit around it. The Sun is a hot gas ball composed of plasma, and it rotates on its axis in the same direction as the Earth. But its different sections rotate at different speeds. For example, at the surface, the area around the equator rotates once every 25 days, and north and south poles rotate more slowly. Due to the high pressure in its core, the hydrogen atoms combine to form helium atoms. This phenomenon is called nuclear fusion. During this event, energy is released in the form of light and heat. Its surface temperature is about 5,500 degrees Celsius and 15.5 million degrees Celsius at core. Parker Solar Probe is the closest approach spacecraft we have ever sent to the Sun. It became the first spacecraft to touch the Sun when it swooped inside the Sun's outer atmosphere, or corona, in April 2021. In 2025, it will be 7 times closer than the current location. Like many energy sources, the Sun will not last forever. It has already used up nearly half of the hydrogen in its core. It will continue to burn through the hydrogen for another 5 billion years. Then, after all the hydrogen atoms in the Sun have been fused into helium atoms, in its last period, it will become a red giant star and expand about 100 times its current size, swallowing up our Earth or maybe Mars. After that, it will burn as a vast red star for another billion years, and then collapse into a white dwarf star. Although the Sun is enormous, it cannot be said that the planets orbiting it are the smallest. They need some qualifications to be a planet. It must orbit the Sun, have its orbit, and the orbit should be such that no other object is disturbed and have enough mass. The 8 planets in our solar system that have these features orbit the Sun in an elliptical orbit. They are in 2 categories: rocky planets and gas giant planets. Mercury is the first of the rocky planets. Mercury. This planet is the closest to the Sun and the smallest in the solar system, with a diameter of 4,800 kilometers. Mercury is the fastest planet in our solar system, which orbits at a distance of 69 million kilometers from the Sun at a speed of 47.87 kilometers per second. It takes 88 days to go around once, but it spins slowly compared to Earth, so 1 day lasts a long time. It takes 59 days to make 1 complete rotation. Life as we know it is unlikely to survive on Mercury due to solar radiation and extreme temperatures. From the Mercury's surface, the Sun would appear more than 3 times as large as it does when viewed from Earth, and the sunlight would be as much as 7 times brighter. It does not have any moons. The surface gravity on Mercury is only about 38% of the surface gravity on Earth. If you weighed 70 kilograms on Earth, you would only weigh 26.6 kilograms on Mercury. In 2012, NASA's Messenger spacecraft discovered water ice inside some of Mercury's craters. Being so close to the Sun, you might still find it strange that Mercury could harbor any surface ice. But some polar crates constantly remain in the dark, despite its proximity to our Sun. Mercury is not the hottest planet in our solar system. With no atmosphere to trap heat, the surface temperature on the planet can swing from 420 degrees Celsius during the day to negative 180 degrees Celsius at night. But the next planet is the hottest in the entire solar system: Venus. The second planet from the Sun orbits at a distance of 108 million kilometers. It is also called Earth's twin. The reason is that this planet is similar in size to Earth and has an Earth-like density. Venus orbits the Sun at a speed of 35 kilometers per second and takes 224.7 days to orbit once. It has an atmosphere 9 times denser than Earth's and is mainly made up of 95% carbon dioxide and 3% nitrogen, with small amounts of other gases. Venus has crushing air pressure at its surface, more than 90 times that of eruption. This dense atmosphere keeps the heat coming from the Sun to its surface and has the highest temperature in the solar system, 475 degrees Celsius. Another trait that makes Venus different from most of the planets in the solar system is its rotation. The usual rotation from planets is to spin anti-clockwise on their axis, but Venus is an oddball, a clockwise rotation. Therefore, on Venus, the Sun rises in the west and sets in the east. A day on Venus is longer than a year, which means it takes 243 days to spin itself once. The surface is a rusty color, peppered with intensely crunched mountains and large volcanoes. It has the most volcanoes present on the surface of all planets in the solar system. On Earth, there are 1,500 known active volcanoes. However, Venus has over 1,700 known volcanoes, not including the smaller ones. It has no moons. It was the first planet to be explored by spacecraft. Researchers have proposed that life may be on Venus's cloud, not the surface. But the next planet is the only planet with life in our solar system, or maybe the entire universe: Earth. Our home planet is the third rocky planet located 150 million kilometers from the Sun. This blue planet orbits the Sun at a speed of 30 kilometers per second and takes 365 days to orbit once, and it spins at a speed of 1,600 kilometers per hour, and it completes one spin in 24 hours. Earth's atmosphere contains 78% nitrogen, 21% oxygen, and 1% other gases, such as carbon dioxide. Earth's atmosphere is unique from other planets because it contains the oxygen that life needs and is the perfect distance from the Sun. 1 astronomical unit is the distance between the Sun and the Earth. With a diameter of 12,742 kilometers, the planet's surface is made up of 71% water and 29% of land. But 71% of water is also located above the land part. It has only one moon, which is our moon. So, although Mount Everest is the highest mountain on Earth, the planet next to it has the highest mountain in the solar system: Mars. Mars is the fourth rocky planet from the Sun, a dusty, cold desert world with a fragile atmosphere. At a distance of 227 million kilometers from the Sun, this planet is the most explored planet by humans. It is a smaller planet than Earth with a diameter of 6,779 kilometers. It orbits the Sun at a speed of 24 kilometers per second and takes 687 days to make one complete orbit around the Sun. Mars, the red planet, has that color because it has high iron oxide content. Like Earth, Mars has clouds, winds, a roughly 24-hour day seasonal weather patterns, polar ice caps, volcanoes, canyons, and other familiar features. And also being close to Earth, it is the first preferred planet suitable for colonization. Mars has feeble gravity compared to Earth. Gravity on Mars is 37% less than on Earth. It means that on Mars, you could jump 3 times higher than on Earth. This low gravity makes it possible for volcanoes to be taller without collapsing. This is why Mars is home to Olympus Mons, a dormant volcano. the largest and highest mountain in our solar system, with 22-kilometer high and 700 kilometers across, making it 3 times the height of Mount Everest. Billion years ago, the nearest planet to the Earth after Venus could be mistaken for Earth's smaller twin, with liquid water on its surface and maybe even life. It has 2 smaller moons, Phobos and Deimos. Even though this planet has a windstorm that continuously blows at a speed of 130 kilometers per hour for 10 days, it is nothing compared to the next planet's storm. We need to look at something significant between Mars and Jupiter before moving on to the following planet. The asteroid belt. Millions of rocks of asteroids are orbiting in this belt. According to astronomers, the asteroid belt is composed of materials that was unable to develop into a planet, or of the fragments of a planet that long ago broke apart. Rocks orbiting the Sun range in size from a few centimeters to hundreds of kilometers. The largest stony object we have found in this asteroid belt is the dwarf planet Ceres, whose diameter is 946 kilometers. Jupiter's gravity ensures that these asteroids do not collide with Earth. Jupiter. The 5th planet is 778 million kilometers from the Sun and is the giant planet in our solar system. About 139,820 kilometers in diameter, this planet can fill 1,300 Earth. If Earth were the size of a graph, Jupiter would be the size of a basketball. It is a giant gas planet, but it has a solid inner core the size of the Earth. The planet orbits the Sun at a speed of 13 kilometers per second and completes its orbit once in 11.86 years. But within just 10 hours, it completes one rotation. So a day in Jupiter is just 10 hours. It has a mass of 318 times that of the Earth and 2.5 times the total mass of all other planets in the solar system. Jupiter is a massive planet, therefore it has a tremendous gravitational pull. Its gravity is 2.4 times that of the Earth. So if you weighed 100 kilograms on Earth, you would weigh 240 kilograms on Jupiter. Jupiter's iconic Great Red Spot is a giant storm twice bigger than the size of Earth, with a speed of 640 kilometers per hour, and has raged for centuries. Its clouds are composed of ammonia and water vapor, drifting in an atmosphere of hydrogen and helium. Jupiter has 80 moons. Ganymede is the largest moon in the solar system, with a diameter of 5,268 kilometers. It is larger than the planet Mercury. Jupiter cannot support life as we know it, but some of Jupiter's moons have oceans beneath their crust that might support life. Scientists believe Jupiter is the oldest planet in our solar system, formed less than 3 million years after the birth of the Sun. Jupiter also has rings, but they are so faint we cannot really see them. But the rings of the next planet are not light like that, much bigger than we think. Saturn. Like fellow gas giant Jupiter, Saturn is a colossal ball. It is composed of the lightest 2 gases known, hydrogen and helium. It is the only planet in our solar system with less than water density because of its lightest elements. Wind speed around the equator of Saturn can be 1,800 kilometers per hour, with a diameter of 120,536 kilometers at the equator. Saturn is the 6th planet from our Sun and orbits at a distance of about 1.4 billion kilometers from the Sun. It takes about 10.7 hours to rotate on its axis once, and 29 years to orbit the Sun. Adorned with thousands of beautiful ringlets, Saturn is unique among the planets. As we already know, it is not the only planet with rings made of chunks of ice and rock, but none are as spectacular or as complicated as Saturn's. The largest ring spans 200 times the diameter of Saturn, but the average ring thickness is only 70 meters. Some of the Saturn ring materials are smaller than grains of sand. Saturn has 83 moons, 63 moons are confirmed and named, and other 20 moons await confirmation of a discovery. Among those, Titan and Enceladus have rocky planets-like surface activities, with a diameter of 5,150 kilometers. Titan's moon is more extensive than Mercury's. Saturn cannot support life as we know it, but its moon Titan surface is sculpted by flowing methane and ethane, which carves river channels and fills great lakes with liquid natural gas. Aside from Earth, no other world in the solar system has that kind of fluid activity on its surface. Saturn tilted its axis 27 degrees, and our Earth tilted a 24-degree angle. But the next planet tilted amazingly and weirdly. Uranus. The third gas giant planet is Uranus. It is approximately 4 times broader than Earth and has a diameter of 50,724 kilometers. Uranus would be the size of a basketball if Earth were an apple. This planet is tilted around a 90-degree angle and appears lying on its side as it's orbiting the Sun, making it unique within the solar system. A billion years ago, Uranus turned onto its side when a large object struck the planet violently. One rotation on its axis takes around 17 hours to complete. Uranus also rotates from east to west like Venus. It orbits the Sun at a distance of 2.94 billion kilometers with a speed of 6.81 kilometers per second, taking 84 years to make one complete orbit around it. Uranus is an ice giant with an atmosphere created chiefly of molecular hydrogen and atomic helium with a small amount of methane. Most of its mass is hot, dense fluid of icy materials of water, methane and ammonia above a small rocky core. This planet's average temperature is negative 200 degrees Celsius. It has 27 moons. Although this planet has surface winds of 1,000 kilometers per hour, the next planet has extremely high wind speeds in the entire solar system. Neptune. This 49,244 kilometer diameter giant 1 is the last planet in our solar system at a distance of 4.5 billion kilometers from the Sun. Light from the Sun takes 4 hours to reach Neptune. It was the first planet to be predicted by mathematical calculations before it was discovered. The planet orbits the Sun at a speed of 5.43 kilometers per second and takes 165 years to complete one orbit. In 2011, Neptune completed its first 165-year orbit since its discovery in 1846. It takes 16 hours to spin itself. Its average temperature is negative 220 degrees Celsius. Neptune is an ice giant. Most of its mass is a hot, dense fluid of icy materials of water, methane, and ammonia in the ice stage. Its atmosphere mainly comprises of molecular hydrogen, atomic helium, and methane. Neptune winds can reach up to 2,400 kilometers per hour, the fastest detected in the solar system. There are at least 5 rings around Neptune. NASA's Voyager 2 is the only spacecraft to have visited Neptune up close. It has 14 moons. The largest by far is Triton. Triton is the only spherical moon. The other 13 moons are irregularly shaped. Triton is also unique in being the only large moon in the solar system to circle its planet in the opposite direction to its planet's rotation. Neptune's gravity is dragging Triton so close to the planet, meaning that millions of years from now, Triton will come close enough for gravitational forces to rip it apart. So our solar system ends with this planet Neptune? Definitely not. That is where the Kuiper Belt and various dwarf planets are located, including Pluto. The Kuiper Belt is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 AU to 50 AU from the Sun. As we already know, 1 astronomical unit is the distance from the Sun to Earth. That means it extends the distance from 4.5 billion kilometers to 7.5 billion kilometers from the Sun. This belt is a donut-shaped ring of icy objects. Hundreds of thousands of icy bodies may be larger than 100 kilometers, and an estimated trillion or more comets within the Kuiper Belt. Thus, our solar system ends in the Kuiper Belt. No. Based on where the planets end, you could say it's Neptune and the Kuiper Belt. If you measure by the edge of the Sun's magnetic fields, the end is the heliosphere. This heliosphere is located approximately 123 AU from the Sun, but the heliopause is the final known boundary between the heliosphere and the interstellar space that is filled with material, especially plasma. Scientists believed the Oort cloud may be the final border of our solar system, which is a spherical layer of icy objects surrounding the Sun, and likely occupies space at a distance between about 2,000 and 10,000 astronomical units. It's mind-boggling to think of the enormity of the entire universe when a tiny average star system is so massive.